CAD is commonly used by manufacturing companies to reverse engineer physical objects. So what we want to achieve in this case is take an image of a physical object and convert that to a CAD or CNC file which can be used for manufacturing. So first we've opened up CAD. We're going to go to Open File and select this image. The first thing to mention is it's important to acquire a suitable image of your physical object. In this case, we've got a gasket which has been scanned using a flatbed paper scanner. That's just a usual scanner that you'd see in an office for scanning paper. The reason that's a good solution for physical objects is because the camera, as it were, is always perfectly parallel to the object. It has good lighting, and as you can see, we have a nice clean white background and a dark object. Some of the problems caused when reverse engineering objects are usually surrounding the acquiring of the image, for example, using a poor quality camera, taking a photograph at an angle, therefore skewing all of the dimensions, and also little issues like camera flash or having a object which is on a busy background. So some simple steps to make sure you have a nice clean image for conversion is going to make your life much easier if you are to do this repetitively. So we have a clean image here of this gasket, and with CAD, what we'll need to do is first treat the image to make it suitable for conversion, and then convert to vector, which can be saved out to DXF, DWG, or G-code file format. So that's super simple with CAD. We can treat the image in two ways. We could use the usual clean raster image tool, where you can threshold the image and so on, or you can use our new grab cut tool. So we go to edit, then grab cut, and this is designed specifically for converting physical objects. So first it asks us to select the part of the image that has the object. I'll say use whole image and confirm. And now CAD has read through the image, looked for parts that it thinks would be the physical object, and isolated it and changed the rest to a black background. So it's already actually done what we need in this case. If it hadn't, we could select background, draw in the elements that we tell CAD this is a background, then click run. However, as you can see, this is all done automatically, so we just click next and OK. And you can see now we've converted the image to a flat image, which is more suitable for conversion. I do see a couple of issues. There's a white dot here. It's probably caused by some dust or something on the object, and CAD has seen that as a whole. So let's clean that up now. We'll go to the clean raster image. We'll just threshold. We'll check remove speckles and holes. And you can see that that speckle has now disappeared in the preview. And I can see some jaggedness around here as well. So we might as well just click smooth to smooth out the lines. We've now got an image which is suitable for conversion. So to convert this image, we go to the Convert Raster Image tool. And in this case, if you're converting for manufacturing purposes, you're probably always going to use the outline conversion method. So select outline, and let's just hit run with the defaults. The defaults are there to give you the best starting point. And you can see the preview of the conversion in the window here, and it looks really good. We've got a nice clean vector outline of the shape. You can compare that to the raster image in the raster tab in the preview. You can even see both together, highlight the vectors, so you can see this pink outline now for the vectors. Now, if you want, we can go ahead and change the conversion. For example, you can choose sharp, where it will really follow closely the pixels of the image, but note that by definition, a pixel image is a pixel-based image. Therefore, you're going to have some jaggedness if you go super sharp. That's why you want to go somewhere slightly on the smoother end. And you can also choose the vector outputs. For example, if your machine only supports polylines, so you can select that. However, we have it defaulted here, as you can see, to lines and arcs. Let's click OK. I'm going to say OK. We can see the results now in our canvas, and we see now that before we just had a raster tab, and now we have a vector tab showing the conversion. We can see both together. So you can see the results, and you could even just go ahead and make some simple vector tweaks if you wanted to. If you're happy with the results, all you have to do now is export the file. So we go to the export button, and let's just name this gasket. And from here, you can save as DXF, DWG, and so on. But there's one final thing that we didn't do, which is to input the scaling. Scaling should be inputted before you export the file. To do that, we go to the measure tool. And let's say, for example, we know The full diameter of this is, let's say the width of the whole gasket is 30 centimeters. So what we'll do is we'll measure from this point to this point, just as an example. You can see that ScanCAD has measured that distance in pixels. And what we're going to do is click the calibrate button. And in our example, we're going to say that this equals 30 centimeters. So we say 30, change the units to centimeters, click apply. And now the whole drawing, this vector file, whether it's a DXF, DWG, or CNC file, now has the correct scaling when it comes to manufacturing. So now's the right time to go ahead and export the file. We could just say gasket, save as your designated file. You can see here the different G-code file formats, should you require that. DWG as well and DXF. Click save and you're good to go. So that's a quick overview of how to use ScanCAD to reverse engineer an image of a physical object for manufacturing purposes.